Welcome everybody to the first video I am making in my series of introductory help videos. I'm going to be making one for each homework going on forward, and I plan to make more involving previous homeworks, previous lessons, future lessons. My goal is to give you a sort of short video guide to everything we're doing that you can play back over and over again in case you miss something I say or misunderstand something. And I will also be adding some text versions of these. I will be including some notes, some instructions, that sort of thing. But for now, let's just start with the video. So, let's take a look at our upcoming assignment, Density, Going Fishing, that is due on October 9th. I'm choosing this assignment because it is not due yet, and that way, hopefully, you can all understand it well enough to get full points on it. So for this activity, you're going to have to open up the simulation link. So I'm going to click on that, although you're not going to currently see what comes up when I do it. And then I'm going to open up this assignment. Now, as always, we are going to go up to Edit Presentation so that we can edit this. And I'm going to edit it in the browser. If you click on Edit in PowerPoint, you may accidentally save this someplace where I'm not able to access it. And if that happens, it's going to be difficult for us to get your work and be able to get it into Teams so that I can actually grade it. So if you edit in the browser, I will always have access to it, as long as you did your work while you were connected to the internet. So here we are. And we can go ahead and zoom to 100% by clicking on that little percent thing down there. It said 47% previously, now it says 100. And we are zoomed all the way in. So I've already opened up the simulation. So let's go over and take a quick look at the simulation. So now we are looking at this page here, which says what makes an object float or sink. So if I go ahead and click on that play button, it will play through a video. So let's go ahead and go back to the beginning so I can read it to you as we go. Alright? Oops. Let's see. Here we go. Question: what makes an object float or sink? When you go fishing, you use bait to lure a fish onto your fishing line. But to do this, the fish has to see the bait first. Because most bait floats, it needs some help sinking in the water so a fish will see it and bite it. Sinkers are used for just this purpose. A sinker is attached to a fishing line in order to sink the hook and bait down to the fish. Not all sinkers are created alike. Can you find a material or create a material that would be a good sinker? So then it will show you the option of replay it or go to the simulation. And here we are in the simulation. Now, let's switch back quickly to the other window. So back in Teams, first thing you have is this question about why do fishermen add sinkers and bobbers to their lines. So that video didn't talk about bobbers. But if you think about a bobber is just a floating object that is higher up on the line that floats at the surface of the water. And you might be able to think about why a fisherman could add a bobber to their line. But you know why they add a sinker, so at the very least you should type why they add sinkers to their lines. So moving on down, it says the simulation should default so you're looking at a wooden block. Unfortunately, we can see that it did not default to that. So let's see. Oh, drat. Hold on a moment. There we are. Took me a second to get that sorted. Okay, so you'll see that it first has you in the Make a Material version. Instead, click on Materials, which will give you a list of materials. The first one is a rubber duck. Here we go. The second one is wood. So, as the instructions said, use the sliders to adjust the mass and volume of the material. So as you adjust the mass, you will see that the volume moves with it. And you'll notice up here in this graph that a dot appears on it. There we go, a new dot appears on it. And another dot appears on it. So that should give you some ideas about what's going on when you change the mass and the volume, and why the mass and volume sliders both change. Another hint is to look at the density of the wood bobbing there at the surface of the water, and look at what it says over there on that plot next to that yellow line. So you will think about those questions, ideas, thoughts, and then you will go back to Teams and you will type, what do you notice as you move the mass or volume slider? And then you go through the other materials and list the materials that you are not able to sink. After that, you're going to go to the Make a Material tab. So I'm going to flip back to the Going Fishing lesson, and we are going to click on Make a Material. You'll see that that circle there has that same kind of particle diagram we've drawn before. And you can, as before, adjust the mass and the volume and see what happens when you do that. Okay, so the assignment then asks you, switching back to the assignment, then asks you to create 4 materials, 2 that float and 2 that sink. This should sound familiar because we did this in class. However, the easy part about this is that you've got the mass and the volume right there in the simulation for you to look at. So you can see, for example, this one has a mass of 5 grams and a volume of 5 milliliters. And I could change the mass to 8 grams. And it'll give you nice round numbers too, instead of giving you decimal points. So that should make their calculations nice and easy too. Alright? So looking at that, you are going to create 2 materials that float and 2 materials that sink, and you're going to put the mass and the volume, and you're going to draw the particle diagram based on what you see in that simulation. Now, second page here, what do you notice about the particle diagrams of the objects that sank, and what do you notice about the particle diagrams of the objects that floated? Once again, this is for you to answer. There's not much else that I can give you, not much advice that I can give you on how to answer that. Then, we're going to have a couple more questions. One, why does a peeled orange sink, and how do fish change their density? To answer those, you're going to click on this right arrow over here. Oh dear, I just realized I didn't switch the view of the... My apologies. Alright, going back. So you're going to click the right arrow over here on the right side of the screen. And then you are going to watch the short video on why does a peeled orange sink. Sorry, it's not a video, it is a little explanation. So you're going to read that explanation, and you are going to repeat in your own words. Remember, never copy, but repeat in your own words why a peeled orange sinks. And then you're going to click on this one for how do fish change their density. So you're going to write in your own words an explanation of how fish change their density. Switching back to the assignment. Lead has a high density and usually sinks in water. Create a particle diagram for sinkers made from lead. Now, there's no really good way to do this, but it says use shapes to create. So, you're going to go up to Insert. You're going to click on Shapes. You can click on Basic Shapes, like an oval. Oh, and that oval appeared up there, so I'm going to drag it down. Make it smaller so it looks more like an individual particle. Plunk it down here, maybe make it even smaller than that. and I can right click on it, copy, right click, paste. Oops. So in that case, it says you have to use your shortcuts, so we're going to use, I'll show you that again. It says your browser can't access a clipboard, so use these shortcuts. So we're going to use Control-C to copy and Control-V to paste, which means you hold down the Ctrl key on your keyboard and press C while you're highlighting something to copy it. Then you let go of that. You hold down the Ctrl key and press V to paste it. So I've hit Control-C, and now I'm going to hit Control-V. Oh, look at that. Another dot appeared. Control-V again. Oh, another dot appeared. Control-V. Oh, I need to move this one, so I'm going to click on that four-way arrow there. Move it up here. See? So you're going to use shapes to create that particle diagram. Now let's move on down to the next page. Here we've got our density equations. So we know that density is mass divided by volume. If you rearrange that using algebra, you can rearrange that so that volume equals mass over density, and mass equals density times volume. For those of you who do not know how to rearrange that equation, I will also post a video later about how to do some of these things. But in the meantime, just accept that those are your three equations that you can get to find density, mass, and volume. So looking down here, a student finds a rock on the way to school. In the laboratory, he determines that the volume is 22.7 milliliters. He puts the rock on the electronic balance, and the balance reads 39.94 grams. Remember that grams is a measurement of mass, and milliliters is a measurement of volume. So you're going to calculate the density of the rock by taking density equals mass divided by volume. Make sure you show your work. And, very importantly, show your units. You cannot leave out the grams and the milliliters or the grams per milliliters for density. You have to show your units because it is very important to keep track of those now and for the rest of the year. So always remember to show your units. Here, a mechanical pencil has a density of 3.25 grams per centimeter cubed. The volume of the pencil is 1.58 centimeters cubed. What is the mass of the pencil? I am going to show you in another video later why volume is measured in cubic centimeters or centimeters cubed. But for now, you're going to find the mass of the pencil. So you go back up, and you find mass equals density times volume, and so you solve that problem for the mass of the pencil. Alright, let's go a little farther. A student performs an experiment with 3 unknown fluids. The following is the starting information for the liquids. That student pours the unknown liquids into a beaker as directed by the teacher. Please draw what the beaker will look like with the layers. So we've spoken about density and displacement and buoyancy. So remember that less dense objects will float on top of more dense objects. So that is true for something like a volleyball, which is less dense than the water below it. But it's also true for liquids. Oil floats on top of water because oil is less dense than water. So, and hot air balloons float because hot air is less dense than cold air. So hot air rises, we know that. Helium balloons float because helium is less dense than air. So, you're going to draw the fluid layers based on which of these fluids is more dense than the others. The least dense one will be floating on top, and the most dense one will be on the bottom. So you're going to draw that beaker labeling the fluid types. Last page. Find the identity of the following mystery objects. So, for the first one, when digging in the backyard, you find an old coin. Its mass is 26.76 grams and its volume is 3.0 milliliters. What is the coin made of? Well, in order to figure that out, you calculate the density of the coin using your equation, density equals mass divided by volume. And then you look at that table up here and you compare the density to the items in that table and see which of the materials the which of those materials the density matches. Alright? And that is your upcoming assignment, your Math of Chemistry workbook, part 2, I suppose. This is what would we name the assignment? Yes, density. Going fishing. So, that is the assignment. If you have any further questions, feel free to let me know. Otherwise, good luck.